Okay, so I have sine here, and then I know cosecant is the same as 1 over sine. So I can write 1 over sine. So sine and cosecant, which is 1 over sine, minus sine squared, or cosecant squared x. So sine over sine is 1, so I have 1 minus the cosecant squared x. That's on the left-hand side. On the right-hand side, all along, I've had negative cotangent, negative cotangent. Okay, so 1 minus cosecant squared. So I come up and I find cosecant, okay, way over here. So if I have 1 minus cosecant, that means I keep the 1 and I move the cosecant to the other side. That's how I get 1 subtract cosecant. Then I'd have to take the cotangent and move it to the other side, so it would become a negative cotangent. So this is equivalent to negative cotangent squared x, and now I have the left-hand side equaling the right-hand side. All right, on the right-hand side, because it doesn't matter if you start on the left or the right. On the right-hand side, I can see that both quantities on the right contain a tangent. So I have tangent squared, and when I factor out a tangent squared, I'm left with secant squared. And then on the right-hand side, when I factor out a tangent squared, I only have 1. And you can see if you did this right, by if you distribute, you get tangent squared, secant squared, and distribute, you get a negative tangent squared. Now secant squared minus 1 would be taking this Pythagorean identity, I subtract 1 to the opposite side, and be secant squared minus 1 equals tangent squared. This is equivalent to tangent squared. And when I take tangent squared times tangent squared on the right-hand side, I then have 4. So tangent to the 4th. And on the left-hand side, I already have tangent to the 4th. In problem number 15 from part 3, I'm going to rewrite the tangent as sine over cosine. So sine over cosine, plus the cotangent is cosine over sine. Now in a butterfly, so I have sine squared plus cosine squared, and then I'm going to multiply the denominators, so cosine times sine. Now cosine squared plus sine squared is equivalent to 1, so this is 1 over cosine times sine. And on the right-hand side, I have secant. Well, remember, secant is the same as 1 over the cosine times the cosecant, which is the same as 1 over the sine. And there we go. I have 1 over cosine times sine, 1 over cosine times sine. Now, I'm not sure if Mr. McFarland doesn't like your final answers to have fractions. This would work. Otherwise, you may choose to transfer at this moment and say, I recognize that this is the same as the secant, and this is the same as the cosecant. And then you could see that the left-hand side would equal the original right-hand side, which was secant and cosecant. Remember that there's more than one way to prove the left-hand side equals the right-hand side. So this works or this works. Drop that. Okay, number 16, I'm going to start by butterflying the left-hand side. So 1, excuse me, 1 plus sine x times 1 plus sine x. So there's 2 groups of that. So 1 plus sine of x times 1 plus sine of x. Then I'm going to put plus sign, and now I'm going to multiply this diagonal. So cosine times cosine is cosine squared x. And that's all going to go over the cosine of x times 1 plus the sine of x. Okay, so I'm going to work on foiling these 2 groups. So multiply the fronts, multiply the outsides, multiply the insides, multiply sine x times sine x, becomes sine squared x, and then you have the cosine squared x that you achieved when you multiplied the second diagonal. I know one of the identities is that sine squared x plus cosine squared x is the same as 1. So I really have 1 plus 1 is 2 in the numerator, plus there's 2 groups of the sine of x. And that's all over this quantity. Cosine x times 1 plus sine x. Okay, so in the numerator, I recognize that both groups have a 2, so I'm going to factor a 2. 2 times 1 is 2. And 2 times 1 again is 2. And the denominator, sine of x, times 1 plus the sine of x is 2 secant x. These are exactly the same, so they're not just going to be eliminated. Remember, they're going to be simplified to 1. And I have 2 over the cosine of x equals 2 secant of x. So the cosine is the same as 1 over the secant. It's reciprocal. So if I bring the cosine up to the top, it's the same as the secant here when I'm flipping it. So this is 2 secant x is equal to 2 secant x. Or maybe you would have chosen to say that you recognize secant is the same as 1 over the cosine, and then they're equal this way as well. Remember, there's more than one way to verify. So in problem number 17, Mary and I have been able to verify that it works, but it seems like this is a really roundabout way of verifying the trig identity. So if you find a faster way to do 17, please share. Okay, so I'm going to start by taking the left-hand side, and I'm going to multiply the left-hand side, both the top and bottom, by 1 plus tangent x. 1 plus tangent x. And as long as you multiply the top and bottom by the exact same thing, it does not change the original left-hand side of this equation. Okay, and then I'm going to go through and I'm going to FOIL. So I'm going to start, this is all on the left-hand side. So I'm going to FOIL front, outside. So front, outside, inside, last. So cotangent of x times 1 is cotangent x. Now outside, cotangent times tangent. They're both positive, so I have cotangent times tangent. Then the inside is -1, and last is minus tangent x. I'm going to do the same thing for the denominator. So front, and then it's outside, inside, and last. Multiply the ones, multiply the positive tangent, then you have negative tangent, and 2 tangents is tangent squared. Why is it negative? One's positive and one's negative. I can see right away that these are just opposite and they're going to cancel out. Now on top, I recognize that, excuse me, I recognize if I just go over the top of this, that cotangent is the same as cosine over sine, and I'm multiplying that by the tangent, which is sine over cosine. I'm multiplying these two when I did the FOILing. Well, the cosines are going to be simplified to 1, and the sines are going to be simplified to 1, so it just doesn't disappear. 1 times 1 is 1, 1 times 1 is 1, so this entire thing right here is a positive 1. And 1 subtract 1, just like I had down here when they're exactly the opposites, 1 subtract 1 is going to be eliminated. So right now on top, I have the cotangent of x minus the tangent of x over 1 minus the tangent squared x. This is all on the left-hand side. All on the left-hand side, and I eventually want to prove that it equals the right-hand side. Okay, what did I do next? I'm going to take just this numerator right here, and I'm going to rewrite it. So I know cotangent is the same as cosine of x over sine of x, and I know tangent is the same, I'm just working right now with the numerator, is the same as sine of x over cosine of x. And then I'm going to go through with that, and I'm going to go through and butterfly it. So I end up with cosine squared x subtract sine squared x all over multiplying the two bottoms, which is sine of x times the cosine of x. This is all the numerator. Okay, so this is the numerator. And now I'm going to work on the denominator. So how can I rewrite the denominator? So I have a 1, which I can write as 1 over 1. Subtract, another way to write tangent is sine over cosine. But our tangent was squared, so sine squared over cosine squared. This is just the denominator now that I'm rewriting. The numerator is right here. I've rewritten the numerator. Okay, so I have this rewritten as the denominator, and then I'm going to butterfly it again. So 1 times cosine is cosine squared x. Bring down the subtraction. Then the other diagonal, 1 times sine squared is sine squared x, all over 1 times cosine squared x. So this is my numerator, and this is my denominator. Okay, and remember, I want to take the numerator and divide it by the denominator. That's what I'm going to do next. So this is another way to rewrite the numerator. So I'm going to write down cosine squared x minus sine squared x over sine of x times cosine of x. And now I want to divide it by the denominator. So normally I'd write divided by, and I'd put this down, this fraction. But I know when I divide fractions, really I turn division into multiplying, and I write down the reciprocal. So cosine squared is on top. So cosine squared is on top, and cosine of x minus sine squared of x is on the bottom. Two I can see are exactly the same groups, so they don't just disappear. Remember, they're going to be simplified to 1. And now if I could multiply across, 1 times cosine squared, that's by the way the same as 1 times cosine of x times cosine of x, if you forgot that. And then on the bottom I have 1 times the sine of x times the cosine of x. Again, simplified, and I'm left with, on the left hand side, I'm left with cosine of x over the sine of x. Now what was on the right hand side? The right hand side was secant over cosecant over secant. Okay, so how can I match the right hand side? Remember that cosine, if I move it, another way to write it, if it's on the bottom would be 1 over, another way to write cosine would be cosecant as a reciprocal. So I could write this as 1 over the secant of x, and sine I could write as CSC over 1, right? Because it's reciprocal. Notice how it's reciprocal each time? So this can be written as 1 over the secant, and this can be written as, since it's on the bottom, then the reciprocal goes on top. So that's another way to write this, and then when you multiply across, you get cosecant of x over secant of x, and now the left-hand side equals the right-hand side. There very well may be a much, much easier way to do this, and I would love to hear it. Let's go on to the next. Okay, so I'm going to look at the denominator, which is secant of x minus the tangent of x. And I'm going to take both the numerator and the denominator, I'm going to multiply it by the conjugate of the denominator. Conjugate means that I write down exactly what is in the denominator, but instead of this time of being subtraction, I'm going to do addition. And whatever you multiply by the bottom, you must also multiply by the top, even the signs. So on the bottom, I'm going to FOIL the bottoms right now. So I'm going to do front, okay, there's 2 secants. Outside, a positive secant tangent. Inside is a negative secant tangent. And then last, I have 2 tangents, and it's going to be negative, so negative squared tangent. Well, the positive secant tangent and the negative secant tangent are going to be eliminated, and I'm left with secant squared minus tangent squared. And I can see up above that if I have secant squared and I move the tangent squared over, so it'd be secant squared subtract tangent squared, it's equal to 1. So I know this portion is equal to 1. That's the denominator. All of this is to work with the denominator. Now on the top, I have the exact same thing twice. I have secant of x plus tangent of x. I have this twice, 2 groups of the exact same thing. So I'm able to write secant squared x. And notice that for this problem, number 18, that's exactly what I'm trying to show. I'm trying to verify that I can have the left side equal the right side. They are, in fact, the exact same thing. Okay, here we go.